Hi everyone, very good morning. So, so I see couple of names here, new ones so that is the reason. Let me give a recap of what we have discussed yesterday. Okay, so just for 2 minutes, all right. So yesterday we have started with, firstly, could you please confirm whether you can hear my voice clearly, and you don't have any kind of disturbance from my side, and you can see my screen clearly, right? Could you please respond in the chat? Otherwise,
Yeah, no issue.
yeah, thank you. And yes, so so these are the terms that we have learned yesterday, and of course, we have seen very good differences between this machine learning, deep learning, and generative AI. How things are a little bit. I mean, what are the factors and what are the main things that are changing each and every subfield? Okay, of course, those differences are not limited. We have few other differences as well, which we'll be covering in regular classes, but for now that is a main concept, okay, on a general level. Okay, so we have seen the definition of artificial intelligence and what is all about. So it is nothing but a broad field, right? So the which is a main field or a domain of machines to mimic human intelligence, right? So that's what we have seen, so which can learn and take decisions on their own. And so nowadays they are surpassing human intelligence as well in almost many of the in many of the fields. And that's what we have seen yesterday. And machine learning, as you know already, machine learning is all about basically it is a subfield of artificial intelligence, as I said earlier. And its main uh, type of activities will be like, we'll be feeding the data, and that particular model will be identifying the patterns in between them. So yesterday we have seen, right? So the if you have this employee salary and years of experience, so it will be finding the relationship between those two independent and dependent variables, and uh, it finds, it can make predictions and all. So it finds the patterns first, and it makes the predictions and all. So basically, whatever the work you give for that particular model, I mean, on this particular example, employee salary and employee years of experience, if you give any type of activity on that prediction or something like that, so it will be easily able to do that. So it as it is already captured the patterns between the data, it will be able to do that, okay, without hard coding anything. Okay, so that is a gist of machine learning. All right, in a simpler level. Of course, I could explain about this topic, say some hours of time, but for now, yes, this is the essence of machine learning. And then deep learning, as we have seen yesterday, deep learning uses multi-layered neural networks, okay, that discover complex patterns automatically. So I have shown you how the neural network is, right? So it is nothing but it was created uh, from the inspiration of human brain. Okay, so based on this, people have created some algorithm, and that algorithms or neural networks are called as artificial neural networks, which we have seen it yesterday. Okay, and then coming to the next field, generative AI. So you already know what this generative AI is all about. Okay, so it is all about focus on creating the new content. So be it text, images, audio, and video, right? So we had some good discussion on these four things in our previous session. Kindly go through the video if you did not attend. All right. So today our main concentration will be on deep learning. Okay. So let me introduce you to this particular concept. And so apart from that, so these are the things I was telling you yesterday, right? So the roadmap for becoming a generative AI engineer, or to be a pro in generative AI, right? So this is the sequence usually everyone follows, and of course this is a sequence one should follow, right? So and your generative AI syllabus starts from here. Okay, so deep learning foundations and all, from here it will be starting. And I have shown you how many hours of deep learning classes we have taken in the current batch that we are teaching right now, right? And from here it will start. Of course it might seem a little bit less curriculum, but we have discussed this in yesterday's class, how much content it is all about. Like, I have kept only 4 modules over here, but it is around 8 modules. I just kept it in a very simpler model. Okay, so that is a thing. And I have discussed on the course features as well. So how and what ways we are following to keep people have the real time experience of a generative AI engineer who is currently working on. So these are a few of the things. And I already told you the extra efforts we are putting to simplify the concepts, right? Which is important. So some of the concepts may be complex, and for imagination also it may take some amount of time, right? So those core concepts we have simplified, and we'll be providing to them during our regular classes. All right, so that those things and all we have discussed very well yesterday. And today, as I was telling you, so today's class is all about deep learning. Okay, so what this deep learning and why this deep learning is very important, and how it is related to generative AI. Okay, so those things we had little information or connection between this deep learning and generative AI yesterday, as I kept one point, right? Generative AI uh, is built upon deep learning neural networks. Okay, so just to tell you simply, all right, so deep learning is very important. And today we are going to look at what this deep learning is all about, right? So I may not have um, I cannot explain the entire concepts within this 1 hour, but I'll tell you the essence of deep learning. And I'll explain you how the model training will be happening. So if you understand that model training, the same can be implemented for generative AI models as well, because generative AI models are also nothing but your deep learning based models. Because whatever the LLMs you are seeing, right? So chat GPT or Gemini, something like that, so they are built upon the transformer architecture. Transformer is nothing but your deep learning neural network. So that's what we have seen yesterday. Okay, so please don't get worried on any of the terms like transformers or neural networks like that. Okay, so we are going to have a thorough discussion, or very meaningful discussions, and in a sequential manner. All right, we will be covering from a very simple manner what it is, how has it come. So you will be understanding, right? So if I introduce you to this deep learning, you will be understanding how we'll introduce you to the concept. Okay, so let's get started. So this we have already seen, understanding the AI ecosystem, so I'm skipping this part for now. Okay, now it is time for us to look at, so I have given enough hype on your on this deep learning, right, till now. So now it is time for looking at these applications of deep learning. All right, so when I say about deep learning, you can see these are all the applications: image recognition, natural language processing, speech recognition, predictive analytics, autonomous vehicles. So these are like simple things. If you want me to expand on the applications, I can say, see, for example, this is image recognition, right? So image recognition means, for example, let's say you are unlocking smartphones with your face, right? Face unlock feature. So that is also dependent on your deep learning. And if you are using Facebook and all, where you upload your photos and your friends photos and all, so it is if you upload some other different photo, based on the tagging that you have made, like if you tagged one of your friends in the photos, so in the second photo when you upload it, it will be automatically detecting that person. All right, so those are also kind of your deep learning applications only. Even airport immigration time also they'll be scanning, right? I mean they'll be taking some kind of impressions or facial things, right? So those are all kind of your deep learning applications only. And next, coming to let's go to this speech recognition. So speech recognition means, as you know, you have so you might be using this iPhone from from let's say some 10 to 12 years. right? So people Apple company has introduced you to some first voice assistants like Siri, right? So the Siri or Amazon's Alexa or Google assistants, Google Live mode, which what you are using today in Gemini, right? So those voice assistants and all are applications of your deep learning itself. Okay, and then comes up your let's say this natural language processing. Natural language processing, as you know, you are using the chatbots, right? The chat GPT and Claude or Gemini, etc., etc. So whatever the LLMs you are having today, so those are all kind of applications of deep learning only, because the deep learning neural networks are the backbone of LLMs as well. Okay, so that important this concept is. And then autonomous vehicles. So see, autonomous vehicles are like so let's say self-driving cars which you have, so which enables vehicles to detect pedestrians, right? And so they can detect traffic signs, and if it is a red sign they'll be moving, and if it is a green sign they'll be stopping, right? So without a driver we have autonomous vehicles as well. As you can see in most of the YouTube videos, AI is expanding like anything, so that I need not to say. So now the cars are safely navigating through the roads without any drivers, right? So in China and USA, so we have lots of this taxi, just like Ola or Uber. So they have this kind of autonomous vehicles where they drop for one person from one place to the other without any driver. All right, so those are also applications of deep learning, and predictive analysis is something other. So let's say the weather prediction, or even the stock market prediction, or any kind of decision you are going to take up in your company based on your past data, or past whatever the survey you have. So those kind of predictive analysis will also be possible using the deep learning. Okay, so this is the other thing. Now coming to this, when this deep learning concept has started, so that is also important, right? So when this deep learning concept started, so it was all started in 1943 actually. Okay, so we have two scientists over here, right? One is Mikulich and Pitts. So when they got a doubt, right? So they got some sparkling idea, you could even say like that. Okay, so these two scientists, they thought like, so however our human brain is working, okay, however our human brain is working, so can we make the machines as well to do or process in the same way? So it is simply like, can we make a machine to learn things exactly like a human brain does? Okay, so that is the idea these people have got. And then that was the time they introduced us to some kind of brain inspired networks. Okay, so for the moment you can keep it like that, and that's the reason I have kept over here. So they want to have the same functionality how the brain is, with some kind of artificial, machine kind of, right? So what is this machine, and how it is replaced the brain functioning and all, we'll see in the next slide. Okay, so I have kept the history of neural networks here. Okay, so this should give you very good understanding on uh, the milestones of deep learning only. So 1943, as I said, it all started, and you can see everything here. But I would like to emphasize on this particular point, which is kind of one historic moment. In 2016, we have this AlphaGo, which is an artificial intelligence program. So it was developed by Google DeepMind. Okay, Google DeepMind, and this was a historic moment because this particular artificial algorithm AlphaGo was able to defeat a world champion in the game of Go. Okay, so if you do not know what this game of Go, it is more like a chess game. Okay, so chess game will be having some thousands of permutations and combinations to make a move, right? But this game of Go will be having a lot more than that. And in that particular game, our artificial algorithm was able to defeat the world champion. So which is a significant moment, right? The historic moment, and the major milestone showing that artificial intelligence can surpass a human intelligence. The interesting thing over here, AlphaGo did not memorize any moves actually. It learned how to play by practicing just like humans. Okay, so it learned the moves and then it defeated the world champion. It did not remember or memorize any kind of moves. Okay, so that's the beauty. That is the beauty of deep learning and the neural networks, right? So yes, you have seen the achievements of deep learning and all. Now is the time for learning what this deep learning is all about. Okay, what is this deep learning, and why it is compared to human brain, and how it replaces a human brain's intelligence, I mean, at least in the machines, right? So let us see that particular definition over here. So deep learning is a subset of machine learning and artificial intelligence that you already know, and you have a better idea on that as well, like here, right? And then it uses multi-layered neural networks to model and understand complex patterns in large data sets. Okay, so this is a little bit confusing at this point of time, maybe for some of you, because these complex patterns and large data sets, these are some words. So if you are new to AI, so these words also uh, may frighten you, right? So just keep things as simple as possible. So deep learning is inspired by the structure and functioning of the human brain. Okay, the neural networks are inspired by the structure and functioning of the human brain. Let me take one example. All right, so firstly, on the left side you have the human brain nerve cell. So if you do not know this, let me keep over here. So your brain is made up of let's say, let's keep it here instead. As you know, this brain is made up of billions of nerve cells, or we can call it as neurons as well. Okay, billions of nerve cells and neurons. So these pass information between themselves. Okay, so one particular nerve cell I have taken and I kept over here. I mean, so if you remember the nerve cell diagram from your schooling, so this is how it looked. Okay, so it will be vertical, I kept it horizontal, that's it, right? And dendrites, see, this is a one nerve cell, and on the left side you can see dendrites are nothing but your input capturing part. Okay, so for example, let's say somebody has pinched me on the hand. Okay, and these pain signals, so since someone pinched me, that pain signals will be traveled towards your brain. Am I right or wrong? Just to sense it. And this is how they will get. So the pain signals will be getting, and through dendrites they will be getting. And we have one more part called a cell body, which will process kind of information like where that person has pinched you. Okay, so whether it is a pain, or whether it is a happy, or whether it is a sad moment. Okay, like that the processing will be happening inside the cell body. And finally this particular information will be traveled to the output kind of parts, which are synaptic terminals, and they will take up the output and send it to some other neuron. All right, so send it to some other nerve cell, you can say it. So this is a functioning. So that's how they pass information between the nerve cells, and finally they'll capture that exactly at what position of your body that pain sensation has created. Okay, so that is the beauty of our human brain. And even our people, so they wanted to create this particular human brain, a nerve cell in artificial way, and this is how it looks. So what they did was this is the neural network. Okay, artificial neural network. Okay, so these are input layers which just like dendrites getting the information. So these will also get the information. And we have hidden layer, so which will process that information exactly at what point in your body that person has pinched you, whether it is a pain, whether it is a sorrow, whether it is a very happy moment, something like that, right? So after this processing has been done, that processing will be shared to your output layer. Okay, so the output is something which will display, okay, exactly at this point people has pinched you and this is a pain, and immediately you'll have to respond, which is nothing but your reflexes, right? So if you can call this as a natural neural network, So if you can call this as a natural neural network, you should call this as artificial neural network, right? So this is a natural one, which is, you know, by default every human is having, and this is artificial thing that a human has created. So if you call this as a natural neural network, you should call this as artificial neural network, and the study of artificial neural networks is nothing but your deep learning. All right, so that is a thing. Of course, this might seem, you know, a little bit difficult for you, but deep learning is a very easy, uh, and of course generative AI is easy. I mean, if you learn this in a sequential and a good manner. Okay, so if you did not go through in a sequential manner, it will be difficult for you. All right, but generative AI, from my perspective, it is easy, and that is the first thing I would like to say. And coming to this deep learning, it might seem some neural networks and all. Please don't get scared on that particular term. It is very easy, and you will not be writing any kind of code for this. We have sufficient you know, frameworks or Python libraries to take care of it. All right, yeah. So this is what the you know, the natural, I mean artificial neural network I have shown you. And to keep it precisely, so this is a simple and single neural network looks like. Okay, so we will see what this x1, x2, w1, w2, and this output layer, right? So you know these three layers: input layer, hidden layer, and output layer. Now let me show this in a different manner. Okay, so this is input layer, hidden node, and output layer. Input layer, hidden node, and output layer. So input, hidden layer, we have number of neurons, and we have output layer. Okay, so this is called as some deep. All right, so this is why it is called as deep, because you have number of layers in between, so it is called as deep and deep neural network. And the study of deep neural network is a deep learning. Okay, earlier I told you, right, the study of artificial neural network is deep learning. So this is also artificial neural network, but it has lots of layers in between, so that is the reason it is a deep learning. Okay, okay, enough introduction, enough you know, technical terms we discussed. And so you might be feeling little bit bored. I know that it's quite common. Now is the time for you know, let's look at some regular example. Okay, so the real time example. So let me start with this a simple real life situation that all of us can relate to, right? So imagine you're on your way to office in the morning. Okay, so you're on the way to your office in the morning, and there is a road you cross every day, right? Of course, most of us, every one of us are crossing the roads each and every day, right? So now think about what you usually do before you cross the road. Okay, so what are the things that comes into your mind when you want to cross a road? Firstly, whether any vehicles are approaching towards you, because they might hit you. Okay, and particularly in Indian roads, you know, you can't believe looking at only one direction. There may be people violating the traffic rules, and they might be coming from this direction as well. I mean, in the opposite direction, which is dangerous, right? And so that is the thing, you will give importance to both what you see and what you hear. So you might hear something like engine sound, or you know, car honking sound, or you know, any kind of horns. Okay, so these are the two important things you give, right? I mean, while you start crossing the road. Am I right or wrong? Yes. So that is a thing I have kept in a simple manner. All right, so inputs are nothing but, so you were wondering, right, what are these inputs, what are these weights? So that is the reason I have taken up this particular example. All right, so we have a person, he is crossing the road, and what will be the inputs will be like, in his brain, is the road clear or not? And the second one being, can this person hear any noises, right? Noises or sounds. Okay, so like car honking sound, or whatever it may be, or even a traffic constable whistling sound. Don't go, man, some vehicle is approaching in your opposite direction. So those kind of things will be in his mind, right? So those are nothing but your inputs. And how much importance you want to give to this particular inputs is nothing but your weights. Okay, how much importance you would like to give to this particular inputs are nothing but your weights. Okay, so the weight is importance of visual input. See, um, let's say you believe what you see, then you will be checking on both sides and you'll go directly. Okay, and there will be a person who gives more importance. So if a person is blind, let's say if a person is blind, he'll be giving more importance to auditory input instead of visual input, which becomes zero, right? But for us, who could hear and who could see, so there we'll be giving importance to both of them, right? That is nothing but your weights. All right, now is the time for you to have a look at how this deep learning model training will be looking like. Okay, so people say, right, so deep learning is difficult, and generative AI may also be difficult because it involves lots of neural networks which we do not know, and it might involve lots of calculations, maths and all we do not know. So those kind of questions are readily available in everyone who would like to learn artificial intelligence firstly, right? So let me show you how simply this might look like. Okay, so this was the um, what is this? This is a simple neural network I have taken, and these are inputs that you know already. X1 and X2 are your inputs. These are inputs, and the importance you are giving to these inputs are nothing but your weights that you already know. And this is a hidden node, I mean hidden layer. And if you have only one circle, I mean this circle can be called as a node, node, right? And we have one hidden node and we have one output node. So since this is output layer, it can be called as a node. And again, this is a output node, and some kind of processing is happening inside the hidden node that I already told you, right? So a person has pinched you and your body should be able to figure it out what kind of sensation it is, and also which body part they have pinched and where exactly they have pinched. So those kind of processings and all, it will be happening over here. Okay, then you should ask me, what is this bias? So why did you keep a bias? You showed only a simple neural network, right? Why did you keep a bias? So what is this bias? BIAS. Okay, so this is your bias. So this is like extra caution. All right, extra caution. So for a person, so let's say this, for this particular person, he might be carefully observing things which is visual input, and this is your auditory input, and that person will have carefulness, right? So few people will have lots of carefulness. Let's say if even if someone sees a car 1 kilometer away, they won't cross the road. And someone, if the car is very much nearer, they'll try to cross the road. Okay, it's all about carefulness, and I am keeping this as a bias. All right, so this is the thing. And for simplification, what I did was, for simplification, at least in the demo or in my first deep learning sessions, so what I usually do is I usually split up that particular neural network. And so two activations are happening, right? One is your sigma, and you can see here, right? So sigma and f. Okay, so I split these two things. I split up like this. Okay, just to tell you what this and what this is all about. Okay, now is the situation for us. um yeah, now is the situation for us. So this is the thing. Let's say this guy, this person is exactly crossing the road. I mean, have taken the decision to cross the road at exactly 8 a.m in the morning, let's say. So these are the two things he'll be looking into, right? Whether the road is clear or not. Okay, so if the road is not clear, I mean any vehicle is approaching towards him, it will be zero, right? And if some kind of car horn heard, then he won't be crossing the road. That is again zero, right? So obviously he will not be crossing the road because already the vehicle is available and coming towards him. So this is a human intuition, right? So when you try to cross the road, these are the two things. So as the road is not clear, he will not be crossing the road. That is the point. And then, so he waited for a minute, let's say 01 a.m. Okay, and for a minute, and he is looking at the road once again the road is not clear, but he is not hearing any sounds. Okay, I mean no vehicles are nearby. Only one vehicle is coming on that road which he has seen, and which is 0 now. And one is he is not able to hear any car sound coming from the opposite direction or in the front direction, whatever. So obviously, since the road is not clear, he will not be crossing the road. This is also fine. And let's say this 8:02 a.m. So again he waited for 1 more minute. So he checked, the road is clear now, the vehicle has passed away, and road is clear now, but he is hearing some car horn sounds. Okay, maybe from the opposite direction, probably he is looking at the opposite direction. All right, so he heard some car sound, and he that input becomes 0, and obviously he will not be crossing the road. Okay, because he is hearing some sound, that is the reason. And then and then we have at 8:03 a.m. what this guy was doing is that he checked once again. His aim is to cross the road, but this time he saw that road is very clear, and no vehicles are approaching towards him, and no car sound as well, which means 1. So he will be this time crossing the road. Am I right or wrong? Obviously. So this is the situation. Of course even we cross the road in the same manner. All right, so let us say we have a machine here. Now in few of the countries, what people have done is uh, they they are using some kind of drones or machines for delivering the food and all, right? So we will have to make that machine think in the same way. Okay, let's say a robot is walking now to cross the road. Instead of a person, a robot is trying to cross the road. Now let us see, we will have to get these kind of outputs from the machine. All right, so that is the point over here. So these outputs should be the result of machines thinking. Okay, but how this happens is nothing but your calculations. Okay, so let me take up this thing. Okay, let me take up this thing once again. This is a machine, neural network or brain. Okay, it is having. And now let me take this particular example only, 111. Okay, 111. So at 3 a.m. he tried to pass, right? So even our model has to cross the road, being the output being 1. Okay, so let me write it over here. X1 equal to 1, like here, this one, and x2 equal to 1. And let's say this uh, what is the next one? Output y true, means y true is the true output. Okay, 1. Okay, so usually to get this output, so the now the we have this human intuition, which is the correct value, and we want the machine to get this particular output. Okay, now for getting this output, it follows two steps that I have told you already. First, it will be going on this particular step. So like this is the way, right? This is a sequence. So it has to calculate this, and then it has to apply some function on it, and finally it gets the output. So that is the point. So firstly, calculate the weighted sum. All right, and then apply function on the weighted sum. Okay, these are the two simple steps our model will be following. All right, so these are the simple two steps. Now so how do we calculate this weighted sum? That is the first thing. Okay, sorry, that is the first thing, right? So let me put over here. The first thing is calculate the weighted sum. So I am representing this sigma as some z. Okay, just for a simple representation, I am representing sigma as z. Sigma means you already know, right? Sigma, what is sigma? Sigma in math is nothing but your summation. That's it. So z equal to the summation being here. So w1 into x1 plus w2 into x2 plus b. Okay, so So whatever the weights you have here, they gets multiplied with the inputs, and along with the b, it comes over this point till here point. Okay, that's a point where our model has to first calculate. Okay, but we know what is this x1, which is 1, and we know this x1 and x2 we already know, but we do not know w1, w2 and b. Am I right? These values we do not know at all. Okay, so why I am telling this particular example is that if you can understand this deep learning example, almost all of the concepts in a deep learning are related to this particular example only. This is the kind of, the core concept of deep learning. All right, not only deep learning, even generative AI as well. So if you can understand this simple thing, so we will almost complete the 30% of deep learning concepts. I mean, not entirely, but 30% of almost all the concepts in deep learning is based on this particular calculation only. Okay, that I would like to say. So see how simple it looks like. So w1, w2 and bias we don't know at all. So let me assume some values. Let's take z w1 as 0.4. So usually I take up some different values for each of the demos. So for different demos I'll take up different values. Okay, so you can also do the practice on the same thing if you want to. All right, so I have assumed these values. Assumed values these are. Okay, so these are assumed values. Now let me do the calculation. So z equal to what is your w1? It is 0.4 into your x1 is 1 and plus w2 is 0.6 into your x2 is 1 again, and b is minus 0.5. Okay, let's do the simple calculation. 0.4 plus 0.6 minus 0.5, which becomes, this is 1 minus 0.5, which becomes 0.5, or otherwise let me just assume uh, b equal to minus 1.5. All right, so let me assume minus 1.5 instead. Minus 1.5. Okay, so I am keeping 1.5 here, 1.5 here. So what your calculation will be now? What your calculation will be now? So 1 minus 1.5, which becomes your minus 0.5. Okay, so z value you are getting now as minus 0.5. So we have successfully calculated the weighted sum. So we must be happy at this point. And what is the next thing we will have to do? So this we have done, right? Now is the time for applying function on it, right? So let me take some simple function. Okay, so we have, so you would have um, gone through few of the concepts in during your undergraduate program like btech and all in the maths, right? So this is a simple function I am taking up. Okay, so if the value of z is less than 0, the output equal to 0. Okay, if the value of z is greater than or equal to 0, which means your output becomes 1, right? So this is a simple function that I am taking up, and I'll do the calculation now. Of course, no calculation is required. You already know, right? So the y value we will be getting here is obviously 0. Why? Because your z is less than 0, right? Your z is less than 0. So that is the reason your y value will be, y is nothing but your output, right? So we have calculated the y equal to 0. Okay, now let me so our model, so it assumed some kind of weights here, right? It assumed some kind of weights over here, right? So whatever, based on this weights assumption only, we got this output, right? So the actual output what we are having is, what is the actual output we are having? We have the actual output as 1, because based on this particular scenarios, that person has crossed the road. So human intuition, which means the person should cross the road, which means even your machine should also cross the road. But it calculated the output as do not cross the road, which is wrong or not? which is absolutely wrong, right? So the actual is, let me take this. Yeah. So control so the actual is y equal to 1, which means cross the road. However, your model predicted the output as y equal to 0, which means do not cross the road. Is this an error or a blunder mistake of your machine or not? Am I right or wrong? So which means, so you should get y equal to 1, but you got y equal to 0 as a machine, right? Which means this is wrong. So what it has to do, so whatever the weights it has taken, zero point 0.4 and zero point 0.6 and b equal to minus 1.5 is the values we have taken right here, 0.4, 0.6 minus 1.5. So based on this weights calculation only, your model has predicted y equal to 0, which means your weights are wrong. Whatever the weights you have taken here, those are wrong. As a machine, it will assume some kind of weights and biases, some random weights and biases upfront, but in our case, so these are wrong. That is the reason instead of getting y equal to 1, we got y equal to 0. This is very simple, right? So we will have to assume, I mean, what is the loss here? Let's calculate the loss. Loss is nothing but y true, which is 1 minus y predicted. Okay, which means 1 minus 0, the loss is 1. Am I right? Which means the error is around 1. So loss means error. Okay, let's take this as error itself. So error here is 1. So whatever the weights and biases the model has assumed are wrong. So what it has to do, it has to update some other new weights. W1 equal to, let's take 0.8 and W2 equal to 0.6 or 7 and B equal to some let's say 0.4, something like that. So it will assume these values in the next time and it will try to fulfill this error or solve this error. Okay, that is nothing but your model training. Model training, whatever may be the model training. So let me write it correctly. So whatever the maybe the weights you have taken, so the random weights we assumed, I mean the machine assumed or wrong. So it has to calculate that loss and in the next time assume some better values. Okay, so it will assume better values and it will calculate the output and all. So this will happen in number of iterations. We can call it as a number of cycles until your this y true becomes equal to y predicted. All right, all right. So these are nothing but your uh, these are nothing but what do we call, we can simply call it as a cycles, right? And if we talk about the general generative AI terminology, this is nothing but model training. All right. So I have been telling what weights and biases, right? What are these weights and biases? So let me take you to one thing. So you would have seen, right? I mean, people usually they boast upon llms, right? So this llm, for example, let's say GPT 3.5 is having 1.5 billion parameters, uh, right? And GPT 4 is having trillion parameters, like that, right? So those parameters, see, this is a simple example. So some large language model we have, some GPT-4 we have. So which is more like your chat GPT, whatever you are using. So GPT-4, it is having parameter 1.76 trillion parameters, right? So these parameters are nothing but your weights and biases. That is the point. Okay, and whatever we told, right, until and unless it gets a correct output, the model is keep on changing this, keep on modifying your weights and biases. That is nothing but your model training. in a very 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 simplified manner. I have given this particular example, and if you can understand this, you know, almost all of the concepts in deep learning and generative AI are dependent on this model training itself. And of course this is how internally a machine will calculate things and finally comes up with some kind of result. Okay, finally it will find the correct output and it will take up the decision to cross the road. I mean, this is just an example. Even the text generation, image generation, or text summarization, text classification, regression classification, so whatever multimodal classifications or something like that, whatever you have, all these will undergo the same kind of steps, but in a different, I mean, in a larger scale. But I have kept this simple calculation for you to understand, or for you to understand the essence of model training. All right, so this is how your model training looks like. Okay, so that's it. And if you get any kind of question over here, so the first question would be, as a generative AI engineer, will I be calculating all these things in my real-time job? So that will be your first question, right? The answer is no. Okay, we have some dedicated frameworks or Python frameworks or libraries like TensorFlow, Keras, PyTorch, something like that. Okay, so these frameworks, you just have to import these frameworks and they will do all the calculations on their own. You just have to write a piece of text or a piece of code. Okay, import TensorFlow as TF. Okay, and even the Keras also you do, and you write that just like this with a simple lines. Okay, this is a line, total line. All right, this is a simple line. So if you write it on their own, they will do all the calculations. Okay, so this is the beauty of deep learning, and this is how the model training looks like. And I have just taken up a real-time example just to make you understand how things work. So usually people think, right, so generative AI is a little bit difficult, that it might involve some kind of great calculations, right? So one thing I would like to say, this is not a rocket science. It is all simple. If you could understand this, as I said, some 30% of the core concepts of deep learning is completed, and of course, even the generative AI as well. All right, so that's the thing. And we have 5 more minutes, and in these 5 minutes, I would like to, few people have asked a few questions yesterday, and I told them that I'll be explaining those things in today's class, right? So how my way of taking you to capstone projects is important, right? So so the real time, for having this real time experience, you should have a thorough building up of knowledge. Okay, thorough building up of knowledge. It should not be like a drastic exponential way of learning, but it should be a step by step processor, and I have taken up this processor. All right, so this is the, sorry, so this is the flow that I do when I come to your advanced generative AI concepts. Where is it? Yeah, here it is. So generative AI concepts, right? Generative AI basics and all. So there, this is where everything starts. Okay, but these are all the foundations, and it's more like if you are constructing a building, so you should have foundation strong, right? So NLP and deep learning will be like that, and of course machine learning as well, that we'll see in the next 5 to 10 minutes. So first, I'll start teaching on your the Hugging Face transformers. Huh. Yeah. So Hugging Face transformers, I'll take up some pre-trained models like BERT T5 and GPT, and I'll be making those API calls on this, and we'll let you know how a generative AI application can be built up. Okay, on the free models. So that is the first thing I'll do, and the next things are like, you will have to get exposure on the open source LLM projects. Okay, so what are these open source models, right? Like Falcon, Mistral, and Llama. So whatever we are having, so those are your open source LLMs. So we will try to build up some projects on open source LLMs. So those are open source LLMs. So once you get very good confidence on open source LLMs, then we will will proceed to the closed source models via API calls. Okay, OpenAI, ChatGPT, or Gemini, or Claude. Anthropic is for Claude. So we will proceed in that manner, where we'll build some projects on these closed source models by making API calls. All right, and once you get some very good clarity on things, what we'll do is that what we'll do is that we will build up some applications in our local system, basically. So local system, in the sense, you will be using Streamlit or Gradio kind of. So there I'll be explaining you to build up applications on both your LLM plus RAG. Okay, so this gives you a very good understanding on how things should be. So once it is done, then it will be time for us, even for you, you would have got some very good confidence on these LLMs, API calls and all, and the project building and all. Then finally we will move to your capstone project, which with the cloud deployment. All right, so this is the last step, and we'll be covering two capstone projects, and this is a sequential way that I will be following. And I believe that this is the best approach of approaching any concept, right? So finally, you by this time you would got very good understanding on things in generative AI. All right, and if you need more information on the two capstone projects that we'll be doing, so I could give you over here. So basically, one second please. Yeah, so um, so these are the services that are available in your cloud platforms. And front end UI and all, it's like hosting your front end application with the Streamlit Flask or React Web UI. Okay, so front end application will build up with a GCP stack like a Cloud Run. So basically it is more like your front end containerized and auto scalable. Okay, so which will be deployed in zero server management. So that's what it all about. And please don't get scared on these terms whatever I speak up. So by the end of the course, you will be using the same vocabulary. So, and AWS will be taking up a EC2 and data storage. Here we have, if you know about something about GCP, we have Google Cloud Storage there. And for AWS we have S3 buckets, AWS S3 buckets. And backend we will be using this Cloud Run again. So this backend API calls in AWS will take up lambda functions. Okay, here also you could use cloud functions, which is very good, which has, this is a serverless service provided by GCP, which will be excellent, right? So cloud functions, which cloud functions means, if you know Python functions, you can simply write Python over here and do this backend API building, right? And model orchestration we'll be doing Vertex AI, and here we'll be taking up a Bedrock and embeddings and vector store. So you'll have a thorough and introduction to these embeddings, like what are all the embeddings we have, OpenAI, Cohere, and Hugging Face embeddings we have, right? So those embeddings you will get a very good understanding. And that vector store we have, right? Chroma, VV8, and we have few more, right? So here I would have Pinecone. So these kind of vector stores also we'll discuss even before we come to this point. Okay, so that will be done, and users data storage. And so these are all quite same, and these are like real-time projects that we usually do as a generative engineer, and I have kept the same things over here, right? So yeah, so by the end of the course, we will be exposed to, I mean, you will be exposed to at least some 20 plus projects overall, some 20 plus projects overall, 20 plus projects overall, and you will have two capstone projects. Okay, so that was the question asked to me yesterday, and I said, so I thought I'll have some good amount of time to explain these things today, right? And now is the time for any kind of questions that you would like to ask. And I would like to, I mean, I see some few people new here, right? So how do we usually make these concepts a little bit easier, is by I have created some kind of simulations. I could show that. Let's take this one instead. So those simulations, what will happen, so they'll make you understand the concepts in a in a short amount of time. All right, so I'll be showing this kind of simulations and all. So this will make you have a thorough understanding on the concept. So that is the reason, whenever I get some free time from my work, I usually spend some time in simplifying the concepts that I can explain to people. So that's what I have done here as well, right? So so like this and all. Okay, so yeah. So meanwhile, you can ask me any questions if you're having. And I would like to say that from tomorrow onwards, the regular classes will start. Uh, and the class timings being 7:30 a.m. to 8:30 a.m. IST. Okay, so 1 hour class you'll have from Monday to Friday. Okay, and from tomorrow onwards, your Zoom link will change, and only to the people who enrolls to the program, they'll be receiving a separate Zoom link. So kindly enroll today. I mean, today, and this information and all will be provided by our management. Okay, and I would like to say one more thing. So whatever the concepts we told, right? So the first foundations like Python, maths and statistics and machine learning will be covered by one good trainer, who is called as Vasant Banu. Okay, and he is currently AI product manager, and he is working in Gartner. Okay, so he'll be your tutor for the foundation level, and almost for the 8 modules we are having on generative AI will be completely taught by myself. Okay, let's say some 20 classes will be taken up by Mr. Vasant Banu, some 20 classes, the foundations and all he'll be looking after, and the rest of the classes whatever we have, so which spans for around 2 months, so that 2 months time will be taken up from the very beginning, and from the zero level will be taken up by myself, which starts from the DE planning. All right, so that is the thing I wanted to say. And today is the last demo session, and as I said, from tomorrow onwards this Zoom link will change. Okay, so please contact our management to get enrolled today, and if you have any concerns and all, you could ask them directly. Okay, they'll be able to answer. All right, and if you have any questions to me, you can ask me right now. Do we have any questions? So if you have any questions, you can ask me, and it is the time for you to ask any small questions. I'll be able to answer. So since it is Sunday, um, so no problem for me. So you can ask me any kind of questions. That is fine. So yeah, and if you want to look how the study material looks like, I have things ready made. I think I have shown you this yesterday as well. So, and I would like to show you again. And this is how your study material looks like. Okay, so it will have the very good information on things, and of course your live classes will be more informative than the study material. It will be like a gist of what we have taught. Okay, I mean, before you go, if you want to revise the concept and all, you can come here and do. But the live classes and the live sessions we'll be having, that will be far informative than this. Okay, so this is how your study material looks like, and we'll be providing the interview questions as well for you to revise before you want to go to interviews and all. Okay. Yeah, so if you don't have any further questions, kindly, I was telling you, right? Please connect with our management regarding this enrollment, how to do the enrollment, and any kind of other questions and all. So they'll be able to answer your questions, and we'll catch up in the regular classes. Okay, so that's all I would like to say. And let I'll be staying here for 5 more minutes, and if you have any kind of questions, you can ask me, or we'll wind up the session. You could chat on the chat box as well. So do you have any doubts in this model training? Does it look complex to you? um, if it any way it looks like a complex thing, kindly go through the recording. This is a very simple thing, right? So the model, it has to finally find the output, right? So it will have these two kind of steps in between, that's all. So that is the thing. And we'll be taking up or assuming the values over here. We'll assume, I mean, we in the sense the machine will assume. Okay, the machine or a model or a algorithm, it will assume things, and it calculates that loss, and it finds that whatever the predicted value we have, I mean the actual value we have, so the prediction is might be wrong. So it finds that it is an error, and as these things are assumed, it will make an second iteration of reassuming some other different values, until and unless your predicted and the actual becomes same. So that is nothing but your training. Okay, whatever may be the training, model training, deep learning training, or generative AI model training, right? So this is the thing. So, and we will have a deep coverage on this in our regular classes, as we have these time constraints, I could not explain to you properly. I mean, I have tried my level best to make you understand the concepts, but we will have these sessions in a detailed manner in our regular classes and all. Okay, yeah. So if you have no further questions, it is time for us to wind up. Okay, thank you so much for attending the class, right? So we'll catch up in the regular classes. Yeah, thank you.